Greetings all LinkedIn professionals. I recently shifted from Spring Boot to Micronaut framework to push the limits, performance, and efficiency in microservices. Micronauts is a lightweight framework and ultra fast startup. Especially, I need this performance oriented frameworks because I'm building an infrastructure related backend services and GUI. Okay, so performance matters a lot. I'm still exploring the other alternatives to achieve the maximum performance, but for now, I'm sticking it to Micronaut. If you see on the this snapshot here, my all the backend services and Angular is going to run here. Angular still I'm running it locally though. The Kafka backend services, the Kubernetes backend services are going to run on this VM as a pod, and the worker node is going to be deployed here. This worker node will be controlled by the K8's master node. This is a master node. And any data related, be it a database or Kafka brokers, they are going to run on these two VMs, K8's data 1 and K8's data 2. For Kafka, K8's data 1 and K8's data 2 will be controlled by the craft, which is running on the K8's master. Building the backend service for the Kubernetes, I realized the need for the rollbacks access control. Every API call, even though those are originating from internally from the pod, must pass strict permission checks enforced by the Kubernetes API server. Remember one thing, Kubernetes API server, where it will be? Kubernetes API server will be running only on the K8's master. So as of now, I have three backend MLs. One is for the Kafka, another one is for the Kubernetes, this guy, and role-based authentication control, role-based access control. Okay, let me explain a bit on this role-based access control. I created a service account here, and the type of this is the kind. If you see, this is service account. The to secure access, I deployed the RBAC YAML first, and I created a service account, which you are seeing it here. The service account, the name is OneShiftSA, and it will define the roles that are associated with the cluster, and it also links the cluster role bindings. This service account OneShiftSA is associated with the namespace 3 apps, and this backend Micronaut service is running inside the namespace of 3 apps. So when the pod starts, the kubelets on the worker node, okay, which is K8's apps, request a service account token from the API server, means that is running on the master node. The API server then uses its private key stored on the master to sign a short-lived JW2 token for the service account. Usually for every 1 hour, the short-lived JW2 token will get refreshed. This is a backend Micronaut controller. You see, these are all the various REST endpoints. I just started defining them. And if you see the Kubernetes service here, the backend service, I leveraged Fabricate Kubernetes client inside. This is the out-of-box API provided by the Kubernetes. This is a front-end Angular, which is a component-driven. One Kafka is built on Angular 19. It is on its own micro front end. KubeShift is on its own micro front end, still yet to build. Once the backend services, I'm getting the proper JSON responses, then building the front end is not a big deal, right? And this home is the host component where all the routes will be with the request that will be routed to the respective backend MFEs. Okay, so I have one Kafka, KubeShift Kafka, two component-driven Angular micro frontends. As of now, I didn't integrate these REST endpoints into my front end yet. You see, this is the health you are checking. This IP address is the K8's node VM and exposed the node port 30909. So you are hitting the REST endpoint directly and checking the health of the backend pod which you're running. And this is another one which you are hitting the backend Kubernetes service to know the list of namespaces. If you see, most of those are default Kubernetes provided namespaces, and this is the only one which I defined my custom namespace. And this is the one, what are all the pods that are running inside this Kate's apps. Okay, so this is one admin, Kafka admin. These two are for the Kafka, and this one is a new guy which developed it for the backend Kubernetes. Okay, so once these are very very basic things, but security is a key factor. Where to, who is going to issue the public key, private key, and how it will be, key exchange will happen, asymmetric key exchange will happen between the worker node even to the master node. These key features you can explore it only in the multi-node Kubernetes. Typically when you go with the single cluster, a single node like minikube or um, kind, it's difficult to understand because there will not be any handshake or the communication happens across pods running from one VM to another VM, right? So once you get the crux of the core Kubernetes, then understanding the solution, understanding any um, client provider solutions like AWS or Red Hat OpenShift, even though it is on prime, or even Azure, that will be conceptually easy.